Fine. So, we have learned about fuzzy implication. So, fuzzy implication basically calculates fuzzy rule, and now we will discuss about how given a set of fuzzy rules we can infer some other fuzzy rules. So, this topic is called fuzzy inferences. Now, so fuzzy inference, in order to understand the fuzzy inferences, we need some discussion about which is very much popular there in predicate calculus or predicate logic. Probably you know that operations, one is called the Modus Ponens and Modus Tollens. I first discuss a bit about the Modus Ponens, and then the Modus Tollens can be understood automatically, and then I will discuss about these rules. Actually, these are the different what is called the logical rules that can be applied to infer some other rules actually. So, let us see first the Modus Ponens. The Modus Ponens is a very famous rule that is known in the predicate logic. It is basically the concept about if the two propositions or two formula it is given to you, how can derive another formula. So, this is in the context of predicate logic, and we know predicate logic is a two value logic, but our fuzzy logic is a multi value logic, only the difference is there, but the most of the method that is there it also applicable to fuzzy logic, or it has been extended to fuzzy logic. Now, the idea it is like this. Say suppose P implies Q. So, this is the one what is called the rule, and P is the another rule. Say it is a proposition or it is a formula, whatever it is there. Now, the question is that, so from this P implies Q and P, whether we can infer something, and if we can, then how it can be inferred. Now, in the context of this inference, we assume that this P implies Q takes the truth value true, that means it is always 1 or is it true. Similarly, this P also takes the truth value 2, that means the two formula which has the truth value 2 and the another formula P, these are the truth value 2, then how another formula can be derived so that its truth value is true. So, in case of predicate logic, all formula use the truth value true and then false is automatically there. So, it is there. Now, let us see if such a two rules are given to you, how we can derive one rule. I can tell a simple algebraic manipulation. So, basically P implies Q and P, I can write the two rule is given P and P implies Q, it is like this. So, the two rules can be combined together to this one. Now, we know that P implies Q is P implies Q also alternatively P written as not P Q, it is basically P implies Q. So, P implies Q also can be expressed in this form. So, using this I can write P and not P or Q, and using the distribution law we can write P and not P or P and Q. Now, P and not P always give the result 0. So, 0 these are P and Q. Now, 0 or P and Q implies is basically P and Q. Now, as I told you P always takes the truth value 1. So, I can write 1 and Q. So, 1 and Q means I can write it is Q. So, what I can say that if given these are the two premises, then we can derive another premises, it is called the Q. So, what I can say P implies Q if it is given and P is given, then we can write it is Q. So, this basically is the basic concept, that is the formula there in Modus Ponens. Now, the Modus Ponens it is like if P and P implies Q is known, then we can conclude Q. Likewise, the Modus Tollens says if P implies Q is true and not Q is true, then we can imply not Q. And this is the chain rule, if P implies Q is true and Q implies R is true, then we can infer P implies R. So, these are the three rules that we have mentioned here. there are many such rules in the predicate logic, that is not the topic of our discussion here. So, we can use this concept to extend it into the fuzzy rule also. So, that is discussion in fact in our next hour. So, it is basically another example that you can follow here. These are the different premises that is given to here, this is there. Now, you can try and you can easily find that from these premises we can conclude about another R or S. So, the concept is like this. Now, the similar concept is basically applicable to the fuzzy algebra, and now we are particularly interested about the two such inferences formula. They are called generalized modus ponens, and it is another is called the generalized modus tollens. So, GMP and GMT. Now, the generalized modus ponens is basically the form. It is basically one rule. We have already learned about a rule. If x is A, then y is B, and this is another proposition. X is A dash is another fuzzy set, where A and B are the fuzzy sets. And one thing you should note that this A and A dash, they should be defined over the same universe of discourse, where B is the fuzzy set, it defines another or similar fuzzy universe of discourse may be. Okay. So, what is the idea is that GMP idea is that if this is given and this is given, then we can conclude or we can infer another proposition, it is there. Why? It is called the y is B dash, where B dash is the another fuzzy set and B dash is defined over the same universe of discourse as B. Now, similarly, if x is A, then y is B given, and here y is B dash is given, then we can infer x is A dash. So, here x is A dash is given, then we can inverse y is B dash. Here y is B dash is given, then we can infer x is A dash. So, this is the two rules. It is popularly called GMP and GMT, and using these two rules we can infer some other fuzzy rules. Now, let us see how these rules can be applied to our different fuzzy operations or sets. Now, so the idea it is like this. So, here basically the input that is given to you, two fuzzy sets A, B, and then either A dash and B dash, and then you have to conclude either B dash and A dash from this. Now, so this basically can be obtained. Now, you can see the first rule that is there, if x is A, then y is B, it can be expressed in the form of a relation matrix, and we can represent R x y. And the next premise is if x is A dash, then that this relation matrix R x y and then A dash can be used and then can be obtained the B dash applying the composition formula. So, it is basically the composition relation composition formula that we have already discussed in previous lectures. So, it is the composition operation. The composition operation takes this form. Now, on the other hand, if B dash is given and if rule matrix is given, then we can calculate A dash using this composition formula. So, it is like this. Okay. So, this is the basic idea, and let us see how we can use this idea to solve our some problems. So, I want to give an illustration about it. Let this is the one rule that is if x is A, then y is B. That means, it can be expressed in the form of a relation matrix R x y, and this relation matrix can be calculated using Jardé's max min rule like that. Okay. Now, let us consider two fuzzy sets A and B, which are defined over the universe of discourse x, and B is defined over universe of discourse y, and the two fuzzy sets are given here and here. So, these are the two fuzzy sets. Now, given the two fuzzy sets, then we will be able to obtain we can apply the GMP, and then we can conclude about the another fuzzy set B dash. So, in order to do these things, so this is the GMP we can follow. I just want to give an example regarding the GMP, another example regarding the GMT also will be given. Now, so this is the GMP can be followed. If this is given in the form of a R x y and x dash is A dash is given to you, then we will be able to calculate B dash. Now, let us see one example in this direction here. So, x is A dash x is a dash, this takes this form where a dash is this one, and we have to derive or we have to infer y is b dash, it is like this. Now, so as it is x is a dash is given and this is the rule matrix and we have to include it. So, GMP is applicable here. Now, let us see how the GMP can be used and then the relation matrix can be obtained. Okay. So, we have to use this formula as we have discussed it, given that R x y is available to us using the Jardé's max min rule. Now, so if we can apply the Jardé's max min rule from the given set A and B, we can be able to calculate A cross B, A cross y, and then finally, the rule matrix R x y. So, here is the rule matrix R x y, this is the rule matrix R x y that can be obtained given A B and then they are universe of discourses, and this is the another input A dash is given to us, then B dash can be calculated like this. So, it is basically max min, that is a composition formula, again this is a max min composition formula we know. So, this means we can apply this one, take the this and this minimum. So, right. So, 0.6 and 0.5 we can take the minimum 0.5, then 0.9 and 1 we can take the minimum 0.9, 0.7 and 0.6 take the minimum and then take the maximum. So, 0.9. So, the first entry is 0.9. Similarly, if we apply this and this we can obtain the 0.5. So, B dash has the membership values for its elements 0.9 and 0.5. Alternatively, we can write B dash as y 1 0.9, y 2 0.5. So, this is the application that we can conclude from a rule another proposition. The proposition is that y is B dash. Now, let us consider another example of GMT. It is the same way, if we understood the GMP, then it is also similarly equally understandable easily. Now, again the same example I can use to illustrate the GMT. So, these are the two universe of discourse x and y, and this is the rule giving the relation between x is A and y is B, and A and B are the two fuzzy sets, it is given like this, and you have given y is B dash, where the B dash takes like this form, and we have to compute the proposition x is A dash. So, here basically B dash is given. So, compute A dash. So, we have to apply G m to, and so this is basically takes this form. So, this relation matrix can be calculated, which can be obtained like this, and then applying GMT we have to calculate this one, that means A dash is equals to B dash composition R x y. Now, here you can check it, this basically not applicable because it is the number of elements 2 and number of elements 3. So, actually we can alternatively we can write it, because A dash should have the elements x 1, x 2, x 3, here x 1, x 2 and x 3 is there. So, I can write it basically this 0.5, 0.5, 1, 0.4 and 0.6 and 0.4. Then the composition, and this composition I can write either this way or we can write in this way, where this is basically y 1 and y 2. So, it is 0.9 and 0.7. Then the different element can be obtained applying this one and this one in direction using max min composition. So, if we apply this one, then the first element 0.5 can be obtained. If we apply this one and this one, the 0.9 can be obtained, and this one 0.6 can be obtained. So, this way we shall be able to obtain A dash given R x y and B dash, and which takes this form. So, this is basically x is A dash, the another proposition. So, we can infer from two rules or propositions the another proposition. The similar idea can be extended to two rules also. Okay, we will see it is shortly. Now, so we have understood about the GMP and the GMT, the generalized modus ponens and generalized modus tollens are the two tools for the calculation of or for the inferences of some other rules. Now, here I just want to conclude with another example, and let us see. So, this is an example here we have considered. Say suppose these are the two rules as given there, and okay, this is the one example. It is there given the two rules here, if temperature is high and rotation is slow. Now, here this high, right, is a basically one fuzzy sets and slow is a one fuzzy sets. This high and slow, the two fuzzy sets are defined over two discourse. One is the discourse of temperature, another discourse regarding the rotation. So, here basically x is the universe of discourse regarding the different temperature, that is basically sets, and then the rotation has certain metrics. So, they are expressed in this form 10, 20, 30 like. So, x and y are the two universe of discourses representing the temperature and the pressure respectively. Now, if I want to express the high temperature, then definitely we have to define one fuzzy sets high temperature. Similarly, if we define the another fuzzy set, say rotation slow or slow rotation, we can define this one. Likewise, high, there may be another fuzzy set can be defined very high, provided that they are difference in the sense that the different membership values for the different elements. Now, let us see what are the different fuzzy sets that we can conclude here. For example, here. So, suppose temperature with the universe of discourse as we have discussed 10 to 100, and we define the two fuzzy sets regarding the high temperature and very high temperature. So, this is basically one fuzzy set high temperature, and this is another, it is called the very high temperature, and you can see the difference is there. It is like either the in terms of elements and then degree of membership or both like. Okay. Now, likewise, regarding the rotation as the universe of discourse, we define two fuzzy sets, one is called the slow and another is quite slow. The slow fuzzy set is defined using this form, and then quite slow is defined this form. Now, so the rule temperature is high, then rotation is slow, it can be expressed using this expression relation, that is the according to the Jardin's maximum composition relation. So, R, this is basically the relation matrix R showing if temperature is high, then rotation is slow. We can calculate this value, and then if temperature is very high is given, then we have to conclude some other in the universe of discourse slow, say it is rotation is quite slow. So, that means this is the one premises given and this is another premises given, and we have to derive another premises or proposition rotation is quite slow. So, we can apply GMP in this case, because this is to given and we have to derive this one, x is a, y is b, x is a dash, we have to obtain y is b dash. So, we can apply GMP, and this is the final formula that can be used to calculate this one. Now, if we take this calculation, we can check that the result that can be obtained, we can check that. So, so here basically H cross S and H cross Y. So, H cross S it can be calculated, if you can check it, I am giving the final result. So, I advise you to check yourself. So, this is 0.8, 1.0, 0.3, it can be calculated 0.8, 1.0 and 0.6 and 0.3, 0.3 and 0.3. So, this basically gives the calculation H cross A S. Now, similarly, this also can be calculated and we can obtain another relation matrix that can be obtained as 0.0, 0.0, 0.0, 0.0, 0.0, 0.0, 0.0, 0.0 and 0.7, 0.7, 0.7. You can verify this calculation. Now, once you know this one, then we can take the the union operation, that means taking the value. So, this relation matrix R then can be expressed R, this is equals to another relation matrix, you can verify this relation matrix that can be given the 0.8, 1.0, 0.3, 0.8, 1.0, 0.6, 0.7, 0.7, 0.7. So, it is given, then it is given like this one. Now, we have to, so this R is available. Now, so we have to obtain the QS. So, we can use this formula VH composition R x y. So, basically composition VH is basically this one. So, we can write 0.6, 0.9 and then 1. So, again the max min rule can be applied and then QS this can be obtained, this and this, it will give the first element, you can say 0.8, then this and they we can obtain 0.9 and this we can obtain 0.7. So, this finally QS can be calculated. So, QS that can be obtained, therefore, it is a overse of discourse this one. So, we can write 10, 0.8, then 20, 0.9, 30, 0.7. So, this is basically the fuzzy set expressing the QS, or rotation is quite slow, giving the fuzzy set, it is like this. Okay. So, this is the way that we can use the GMP and GMT to infer fuzzy relation. Now, so we have so far discussed about the fuzzy implication or inferences, rather inferences given one rule and one proposition. In the next lecture, we will discuss about the fuzzy implication whenever the two or more rules is given, and then how the another rules can be obtained from them. Thank you.